The definition of a compound inequality. A compound inequality consists of two inequalities joined by and or. We've used and or a lot in our lives. If I were to come in the door and I were to say, Riley and Erica go to the office. Who goes? They both do. If I were to come in and I were to say, Kinley or Caitlin go to the office. One of them. And means it must be true for both, or it's true for one or the other. So a compound inequality is two inequalities joined with and or. And is true for both, or is true for one or the other. Everybody good? Okay. Here's what we just said. Solutions to and solutions must be true for both inequalities. Or solutions must be true for either of the inequalities. Like I talked about with the students. If I say and, they both go. When I say or, that means one or the other, but not necessarily both. Have to go. The ands are true for both. Ors are true for one or the other. Okay. Take a look at an example. This is an example of an and. Majority of the time you're going to find ands where we join them as a one inequality, just joined with two parts. Okay? Our goal, same as always, isolate the variable. Instead of having a left and a right, though, we now have an additional part. We have a middle. So, my question, of course, is to begin with, we can't solve the variable until we find it. Where's the variable at in this? Is it left, middle, or right? Middle. Oh. There it is in the middle. That means everything we do is going to be based upon the middle. So our goal, remember, what's that word we were talking about that helps us to remember the order that we solve an equation in? SADMEP. Yep, we're not happy, we're sad. And the S and the A in SAD stand for? Right. So we undo the subtractions and additions first. So in the middle, they minus 8. What are we going to do? Here's the twist when you do the compounds. You're not going to add it twice. You're going to add it 3 times. You add it to the left of the inequalities, you add it between the inequalities in the middle, and you add it to the right. Do it to all 3 parts. So over here on the left, what is negative 2 plus 8? Not negative, but very good. Positive 6. 3x in the middle. The 8's cancel out, which is what we want. So we've undone the addition and subtraction from the variable part. Now we have to undo, how do we undo the 3 that's attached to the end? Correct. X is by itself, you're done. If your problem starts with 2 inequality symbols, it ends with 2 inequality symbols. Don't think, okay, I'm going to move that 2 to the 6 and combine those. No. You're done. X is by itself. That's the whole goal. Isolate. Okay. Like always then, since these are inequalities, we're going to have to graph these. Your graphing's easy because I believe yours is kind of done for you on MathXL. You just have to pick it out. Ladies and gentlemen, can you describe the location of X for me, please? Just in general, where do you see X at in the problem at the end, Mr. Griffell? No. Right here in this answer, where's X? It's in the middle. In the middle of what? 2 and 6. That's the same way we're going to look at shading. Since x is in the middle of 2 and 6, we're going to shade in the middle of 2 and 6. So the first dot goes to 2, filled in or open?
Filled in.
Because we're equal to, correct. Second dot to 6, also filled in. Just like x is between them, our shading goes between them. 2 is, bring this back on. Take a look at this, an example of an OR. When you have an OR, you just have to do them as two separate problems. So here, 3x plus 1 is less than 4. DeMonte, what are we going to do to solve for x? Not yet. Remember, we're sad.
I don't know what that means.
You remember PEMDAS?
No.
Please excuse my dear Aunt Sally. Okay.
I really don't.
All right. What it means when you evaluate an expression, you know, if I gave you 3 times 4 plus 8 minus 1, how we have an order that we do it in, where we would do the parentheses first, and then we'd multiply. Okay. When we solve an equation, we go backwards from that. So therefore, when we solve an equation, we're looking to undo any subtractions and additions first. So on the side where x is at, are they adding or subtracting anything to the term with x? So what are we going to do? Correct. Not a problem. Again, if it helps, here's my variable. I box the variable and everything connected to the variable directly connected to those operations that was in between. So Monte's correct. We're going to take away 1 because they added 1 to the box. Thank you. You're the official mouse mover. Then we'll divide by the 3. What do we get? X is less than 1. So that one's done. In an OR, you don't really work the problems together. The AND, like we saw back here, we kind of do things at the same time. We add 8 to all 3 sides. In an OR, you don't. You just work them as two separate problems. So let's take a look at that second problem. And again, let's find the variable. Oh. Here's my variable. And again, if you're struggling to see your sides, you can still do like always and put a line between them, because that helps to identify my sides. Mr. Guttrell. Correct. Looking to undo the subtractions and additions first, so they minus 5. So we'll turn around and add 5. Does in fact give us 12. Final step. Mm-hmm. Again, since this is an inequality, we're going to have to graph it on a number line. Let's see. How about -2, 0. Now, don't panic, because we're supposed to be comparing. A dot has to go where? For this first inequality to the left, where should my dot go? But I didn't put 1 on my number line, did I? Where does it go? In the middle. You can scale it by something else. Don't worry, but the 1's not there. We know 1's in the middle of 0 and 2. Do I fill that dot in or leave it open? And where do I shade to show all the numbers that are less than 1? To the left. X is greater than 6. Another open circle. In this case, going to the right. Generally, 99% of the times when you do an OR, you're going to have two separate regions. And joins the regions together. Okay? It's kind of like, I don't know if you guys seen them on YouTube, the conjunction junctions, what's my functions? And hooks things together, or separates things. I should have thrown that into today's lesson. All right. Ms. Shelton, this is what you were asking me about. So again, I'm going to separate my sides. I got 3 sides this time. Where's x at? Oh, okay. We're not happy, we're
Sad. But today I'm happy.
So that means we look to undo the subtraction and addition first. We're working off the middle part, because that's where the variable's at. So in the middle, what has to go away first, because it's not with x? Minus 2 has to go away. Remember, to get something to move away, it's the opposite of what it is. So since this is minus 2, plus 2. But do it to all sides. Okay? Now, with this, what's negative 2 plus 2? That doesn't mean you lose it. You still have to have 2 inequalities here. Okay? You start with 2 symbols, you end with 2 symbols. The middle gets rid of the 2. We're still left with negative x. By the way, what's really with that x, even though we don't see it? We don't want a what? A ninja one. Why is it a ninja one? Okay. Ninja one. So what are we going to do to get rid of the ninja one? Actually, the ninja negative one.
We're going to divide the ninja negative 1.
Again, don't panic. Oops, messed that up. That's 0. Since we divided by a negative, what happens to the inequality symbols? They switch. They both switch. Because you divided by a negative, they both reverse. Reverse, reverse. Isn't that a song?
Yeah.
The inequality slide. I can see it now. It's a new dance craze. We'll have to start. Okay? Questions on 3. Okay. All right. Part of what you have to also be able to do is to write a compound inequality. X is less than 8 and greater than 3. I want you to take the words and translate them to an inequality. Well, if we did it this way, x is less than 8. Well, x is less than 8. Greater than 3. Can anybody turn that other one around? Instead of x is greater than 3, what's the equivalent to that? If I flipped x is greater than 3. Miss Teeny?
3 is less than x.
Correct. So if x is greater than 3, that means 3 is less than x. And imagine we took this, 3 is less than x, and we just kind of moved it over here. So the x's will be on top. X is less than 8 and greater than 3 means 3 is less than x is less than 8. This is your final answer. Anybody think they got number 2? X is less than negative 2 and is at least negative 4. Okay? Yeah, I don't have a symbol for at least. Not less than.
Oh, great.
Greater than. So this is what it would look like. Now, how do I make it a single line one? How do I make the answer look like this answer up here that I'm putting an asterisk next to? Mr. Roulette.
Negative 4 is less than or equal to x less than negative 2.
Very good. Pretty much when you write these inequalities, think about a number line for a minute, guys. Remember how the number line always goes up from left to right? So when you write these, you want your smallest number to be on the left. Negative 4 is the smallest. It's going to be on the left. Okay. Finally, number 3. X is between negative 10 and 7. So you're literally going to write x between negative 10 and 7. And you always use less than symbols. Now, one little word at the end here. What's inclusive mean? In math, in life, what's world inclusive mean? Ned, what do you think?
To include something.
Something. What do you think I want to do with my inequality symbols then? Yep. So if I want to include those negative 10 and 7, what do I have to put underneath them? How do I include negative 10 and 7 in my interval, if you will? Because they're inclusive, that means I want those numbers, means they're equal to. Okay, all right. Last one. Interval notation. Interval notation is just a different way of writing a compound inequality. A bracket means that you're equal to. A parenthesis means you're not equal to. These are going to look like ordered pairs. Okay? For example, negative 8 is less than or equal to x, which is less than 2. That's an inequality notation. Why? Because it has inequality symbols. Interval notation doesn't use symbols, it just uses the values. So what you would do for this means that you're going to be negative 8's your smallest and 2's your biggest. Equal to means a bracket. That's a bracket on negative 8. That's a parenthesis on 2. Negative 8 is less than or equal to x, which is less than 2. Means that your interval goes from negative 8 to 2. When you're including negative 8, it gets a bracket. Not including 2, so it gets a parenthesis. The example right below that, 14 is less than x, which is less than 21. That means we're going to be between 14 and 21. Are we including 14? So therefore I use a parenthesis or a bracket. Bracket means I am and it is equal to. What about 21? Parenthesis or bracket? Parenthesis. What are you thinking so far?
I hate it. It's easy.
Okay. When you do interval notation, your smallest number is always on the left. X is greater than or equal to negative 3. If we're greater than or equal to negative 3, what's the smallest number we're going to be? If we're greater than or equal to negative 3, what's the smallest? So negative 3 comes first. It's equal to, so do I put a bracket or a parenthesis? Greater than or equal to negative 3. Someone name me a number that's greater than negative 3.
6.
2, 6. Keep going.
100.
54, 100. Where are we going to stop at? Never. So in mathematics, if we never stop, it's infinity. Very good, Miss Shelton. So remember what the infinity symbol looks like?
Side of it.
I can't draw these.
Okay. Negative 3 to infinity. Infinity is never included. You can never reach infinity. Just like that movie character from the 90s. He was always going where? Infinity and beyond. So you never reach infinity. Therefore, infinity never gets a bracket. Infinity is always a parenthesis. Bonus points if you can name the character.
What about you?
Yeah, that's cool.
Yep. My daughter was born in 1995, and I think that was the first video she had of Toy Story. Of course, she was really a Lion King person.
Lion King.
Okay? All right. Let me write this example back up again because it kind of got lost in the wash here. How about x is less than 5?
That would be in 5 first and then be in parentheses.
Well, let me ask you this. If we're less than 5, what's the biggest number our bracket's going to have, interval's going to have?
5.
Right. Remember, the smallest number is always on the left, which means the biggest number is on the right. So if 5 is the biggest, 5's on the right. Parenthesis or bracket on it,
Parentheses.
because we're not equal to. Give me some numbers that are less than 5.
51.
Right. Very good. Whoever said that. Okay. Infinity has both a positive end, getting bigger and bigger and bigger and bigger and bigger without stopping. Also has a negative end. Negative infinity to 5. Okay. Well, let's see if you guys can go backwards. Reverse, reverse. Can you write this in inequality notation? Miss Knotts? Nope. Your answer should look something like this. Yes, Clarissa.
2 is less than or greater than. No, 2 is less than x. X is greater than 12. Greater than. I mean, less than or equal.
Correct.
You need to do my homework.
Okay. If your interval goes from 2 to 12, that means x is between 2 and 12, and it's less than symbols. Always less than when you write these intervals, guys. What about this? Change my colors up here. Write it to me as an inequality. Roulette.
6 is less than or equal to 6. X, like infinity.
Mouse mover.
X is less than infinity.
Nope. Yep.
X.
Nope. Cottrell.
Ooh. I think I got it.
I can live with that. How can I rewrite 6 is less than or equal to x? What's the equivalent inequality to that?
X is greater than 6.
Correct. That's what MathXL is going to want to see. 6 is the smallest because it's on the left of the interval, so we're greater than or equal to 6. All right, that is your lesson on compound inequalities. Not yet, not yet.
Serious.
You guys have questions for me?